Welcome back to Suit Up and Hack. In this video, we're going to dive into the ransomware that we took a look at in the previous video. In that previous video, we took a look at the JavaScript dropper, that malicious file that took the base64 encoded file, decoded it, and dumped it into an executable and ran it. Now, we're going to actually take that executable and we're going to put it into a .NET disassembler and see what it does, what nefarious actions that it takes. So stay tuned.
We've seen how the dropper gets the malware onto the computer in our last video, but what happens next? This video, I took that base64 encoded string, put it through a simple Python base64 decoder, saved it as Nebula Run.lnk, and brought it into a decompiler, a .NET decompiler to be exact, so that we can better understand how this ransomware encrypts files, spreads to other devices, and finally calls home to the attacker. Our starting point here is we already have everything opened up, and you can see there's a lot here, a lot of different system libraries, etc., cryptography. But the main thing that we want to look at here is this Nebula Run, which equates to that exe file that I created and decoded from the base64. I want to take a look first at the main function, that entry point, so that this is the first code that runs. As we can see here, this AppDomain.CurrentDomain is quite an interesting function in that it's dropping all the DLLs that it needs onto memory. So this is taking it and clever way to embed all the required DLL libraries directly onto the file itself, rather than dropping a bunch of separate .dll files onto your computer. So it bypasses some of those static analysis that happens and a lot of other shady things, as you can see here. But it basically packages it up into a Nebula Run.dll. It then begins to encrypt all. What this function does, it basically is the ransomware, that main payload. So if we click on that, and we're going to jump to the, I think we're going to jump to the EncryptAll, and we just scroll down just a little bit here to see it. And here we can see that it's first going to use these, it's AES Encryption, decryption, key size of 128, block size of 128. It calls generate key, and then it also will call this IV as well. And the IV is referred to as the initialization vector. So it's trying to make sure that everything is unique. It's a randomly generated starting combination called an initialization vector to ensure that even identical files look completely different once they're encrypted. So we're setting the key to what we generated. We're setting the initialization vector to what we set. We also have target directories that had been, it's basically if we want to think about it, all the common strings that a target directory would take a look at. And if it finds that, for each string text, if that directory exists based upon this text check, we're going to encrypt the directory. Now we can go ahead and take a look at what EncryptDirectory is, which takes a string of what the directory is, the key, and the initialization vector, and get files. And so for every basically file name within the files, if it does not end in this .nbl, we're going to encrypt it with the file name, the key, and the initialization vector. And if we go back and take a look at what EncryptFiles is, it's the payload. We're diving in, we're reading all the bytes in, and we're setting all the keys, the initialization vector, CryptoStream, we're writing it, and then writing all the bytes back into and adding this .nbl and deleting that previous file path. So that basically dives down. For each directory, we're going to then check each file, and for each file that doesn't have an NBL, we're going to use this EncryptFile function to create the CryptoStream, which is the gobbledygook that you won't be able to see once it's encoded. Going back then to the main file, we took a look at EncryptAll. How does it spread? It spreads with these two functions. USB, which is basically it's taking a look at each individual, it basically takes a look to see if there's any, or identifies for any removable media. So let's click on that and then go down and check, and it's taking a look at try USB spread, and we go down some more, and basically it's doing additional checking drive type, getting the drives, getting the current processes, and bringing that in to this array, and just seeing if going to be basically dropping these files, this hello.text.exe file and this autorun.lnk file, this link into that removable media, so that they take your USB stick and put it into somewhere else. This will run. This will generate and create the drop Nebula basically onto another unsuspecting computer when it gets moved. Now let's take a look at the LAN spread, which is the local area network spreading mechanism here. So we go down, and we're going to go ahead and dig down a little bit further, and essentially what this is doing is it's identifying the local area network that the infected computer is on, and it's going to get the local subnet, and then it's going to start basically pinging for seeing if other ports are open, and go ahead, and if it is, well, it's going to then go ahead and drop this exe file onto that open drive, and it's going to use common passwords or looking for admin shares and so forth in this. So I encourage you to go ahead and you can go out and get this sample on Malware Bazaar, or if you need it or would like to do some checking yourself, please feel free to drop some comments in the chat, and I'm happy to assist you with that. But the final piece then is going to be, we're going to go back to main and go ahead and see. So we took a look at that. With the USB spread, it's looking for removable media. With LAN spread, it's looking the local area network, seeing if it has any open ports, from 1.2. The local area network's IP address is 1 through 255. and spread it that way. It is then going to go ahead and send the information back. This is the command and control. This is ET phone home, for those that remember ET, the extraterrestrial, when he was phoning home. And how it phones home is it's going to be going in and running a post request here to this Discord server address, and it's going to basically be sending everything, which is the victim code, base 64 key, initialization vector, and so forth. So it's uploading all of that, and it's going to be uniquely generated victim code because it's based upon, I think it's the MAC address or something unique within the victim's computer itself. So the victim, it gets uploaded to this Discord, and of course it's this information right here, the enable visual styles, text renderings, and that is the basically the resources that it's going to be using to go ahead and drop that note, that ransomware note, to say how to get in contact with that. So make sure to stay safe out there. This was dropped, or I've downloaded it from Malware Bazaar just a few weeks ago. So when we were going through the dropper and this Nebula Ransomware file, we can see that this is some most recent indication that this stuff is still out there. So make sure you're safe when you're looking for this, and make sure to hit that like and subscribe button, and you'll be getting a recommendation here for a next video. So thank you, and make sure to hit that next video to continue your cybersecurity journey. Thanks.